Hello guys, and welcome to this video tutorial of Autocad 2018. A few weeks ago I uploaded a video explaining and showing how to 3D model an M10 bolt. I've had a few people asking me, wait a minute, what about an internal thread? What about if you want to model a threaded hole or a threaded nut or whatever? So I will be covering that in this tutorial. So I've just opened Autocad. So I will sketch one up quickly. If you've watched the previous video or you know how to do this already, just skip the video forward. So I won't be explaining all of this step by step. I will just quickly sketch it because it's all in the previous video. So just a quick tip. If you type C, circle comes up, and then if you right click, then it draws a circle for you. It's just a lot quicker than having to type in the whole command and pressing enter. So C, right click. Okay, so I'm going to draw my circle. 5mm. Now I'm going to extrude at 30mm. Now I'm going to draw my helix. My pitch is actually going to be 1, just to keep things a bit simpler. My height, I'm going to make it a little bit above the top edge, so I'm going to say 33, just so it threads the entire thing. Now we'll have a look at my layers. I'm going to create a layer for my thread and a layer for my bolt. I'll use the chamfer edge command. So it's not chamfer, it's chamfer edge. Select my edge. Enter. Oops. I cancelled it by accident. So now I'll quickly transfer these to my other layer. Now as usual, I will create a Z-axis, UCS, Z-axis is going to go in that direction. And now I will quickly draw the thread. So 0.875. Offset by 0.54 of a mil. Minus 30 degrees. Positive 30 degrees. Keep all of this trim. Join this. Now we'll move it from this point to this point. And now we'll use sweep. I'm going to select my base point. Just so you know, make sure that alignment is turned off by default. See, that's what actually happened. So I'll go back. Then when I go on sweep, here in the alignment option, I'll click on it, and then as you can see, it's set up on yes by default, so I'll click on no, give a base point, that one, select my sweep path. I'll move this up by 1 mil. Turn my ortho mode on. Just moving it 1 mil up because I had a chamfer on my and now I'll go back to my UCS world. So if I now subtract this, select, right click. Oops, I did it the other way around, sorry. So subtract, select the object that you want to keep, right click or enter, select the object that you want to delete, right click or enter. As you can see, I've got my thread here now. Okay. So next thing that I'm going to do, I'm going to draw my hole. So I'm just going to sketch a rough plate. So I'm going to draw a rectangle. And I'm going to draw a circle here at the center. And the radius will be 5 mil. So if I now press pull that, So I'll make it, for instance, 20. So if I now move these, and I will paste it on this center. Okay, so now that I've got it in the right place, I will move it down. Roughly up to there. Maybe I'll move it down a little bit more so it covers the entire hole. There we go. So now when I use solid subtract, select object that you want to keep, right click, select object that you want to remove, right click. Nothing happened, and the reason why is because the diameter of your bolt has the same diameter as the hole, so you can't use your nominal diameter for both. So if you already have your hole and your bolt, there is a way you can edit it. So what I'm going to do, I'm going to transfer my bolt. I'm going to turn that layer off. And now, what I will do, I'm going to use the solid edit command. Select the face option. I'm going to click on the option called offset. I'm going to select this face, right click or enter, and then I have to specify the offset distance. So obviously my hole needs to be smaller than my tap size. So if my thread is an M10 and the pitch is 1, the drill size should be 9.1 mil. So that means that my offset needs to be minus 0.45, because the diameter needs to shrink by 0.9, so my radius needs to shrink by minus 0.45. Exit. Exit. Actually, it did it in the positive direction, so I'll use solid edit again. Face, offset, so 0.45. There we go. So now I can bring my bolt back on. So now say if I use subtract, there we go. You have your thread in there. So this is completely fine for a 3D model. The only problem is that in reality this simply wouldn't work, because there is no tolerance. So the thread of the bolt would be grinding against the internal thread of the hole, so it wouldn't run through. Again, as I said, for a 3D model, it's best to just leave it like this, and then on your 2D drawings you can indicate the drill size, the tolerance, what bolt and what internal and external thread you're using for each. Normally, you don't even model a real thread, because as you can see, my computer is struggling. Your computer will probably be struggling and lagging to load this feature. Normally on 3D CAD, they insert an image of a thread. I think I can show you here. So if you have a look there, that's not a real thread. That's just an image. So the computer saves some effort by doing that. It makes your model less heavy. I think I have a few more. Yeah, you can see it here as well. This is a model that I drew a while ago. You can probably see it in the reflection. In some models, it actually looks more realistic. If I show you, that's also an image of a thread. However, it looks a little bit better in there. So, I still know that some of you want a really perfectionist, and you want to 3D model your internal and external thread to the right tolerance. So I will be showing you that in the next part of this tutorial. So, for instance, let's say that you want to model your threads to the appropriate side. I will post a couple of links, a couple of resources that you can use. This is a thread tolerance calculator, and this other resource shows you all the dimensions, and it provides you with a chart where you can find your right diameters after you apply a tolerance. So I've extracted all of this information from the link. I've got an M10, my pitch is 1, so I've highlighted it here, and I've got all of that information put it into my own Excel sheet. It simply looks a little bit better and easier to work with that. So I've got my size, my pitch, and then I've got all of this information for my internal and external diameters. You have to be careful with that because it says diameters. So even though this line is here, this line would be the center of the bolt, but obviously these diameters, it would be the distance from this feature to the very bottom. So instead, I would like to work from the central line and use it as a datum. So I've divided all of these diameters by half. So I've got my radius values here, which are half of the values on the top. So from that chart that I showed you earlier, I extracted these values, plotted them here, calculated my average, so I can use my average for modeling it because it only gives you the maximum and the minimum. So from those values, I can get this on AutoCAD. So I'll be showing you how to do that. So I'm going to start by drawing a line. First point is going to be the origin. Just give it any length really. Doesn't really matter. Okay, so I'm going to create a couple of layers. One of them is going to be my internal thread, and I'm going to change the color to green, like in the chart. My second is going to be my external thread, and I'm going to change the color to red. Okay. So I'll start with my internal, probably. I'll probably start with nice. Yeah, probably my internal. So I'll change these to internal. Now if I get my internal starts here on diameter 1, just D1, so my radius is 4.518. So I'll select my line, offset it there. Looks like I'm still not on the right layer. Okay. And my top will be D, which is 5. So offset 5, 5. I will do the same with my external thread. So my minor diameter is, my radius is 4.372. And my major diameter is 4.942. I'll move it to the other layer, so okay. So I know that goes at an angle of 60 degrees. So 60. I also know that this distance is P minus P over A plus 0.875. So I'll snap from this line, then type in 0.875. And then that goes at an angle, obviously that's 90, so 19 plus 30, 120. It's good. And now I'll give all of this a trim. I'll join them. So now I will do the same with the other one, with my external thread. Again, I know that that is at an angle of 60 degrees. And I know that that's 0.875. That's going to be at an angle of 120. And now I can trim all of that. Trim a little bit more by accident. There we go. And now I can join all of these. So if I now move it, that edge has to be vertically aligned to that edge. So that's it. This would be my internal thread, and that would be my external thread. It looks like there is a huge gap in between. However, as soon as you zoom out, you see that the gap is actually not that big. It's what a real bolt would have. So, having applied the right tolerances, now you can apply this to a real thread. So you would use this one in order to cut your external thread. So you can use this one to make a bolt out of it. And now you could use that one to make another bolt out of it, but this would be the bolt that you use to subtract from your hole to make the internal thread. So I'll probably do that in this tutorial, so at least you can see it working. So I'm going to start by, I'll probably start on this view. So I'll do the same, draw a helix. I'll draw my my circle first. Radius is 5. Helix. Now, as usual, our UCS So I'll move this pattern to that one. And I use 3D rotate to rotate it. That's going to be my base point. So I can then rotate it 90 degrees. This direction. Degrees in that direction. So what I'll do, I'll make a copy of this one. I'll rotate it. Move it. And then I'll change this one across layers. So it's going to be my real bolt, and that's going to be my so-called mold for my female thread. So I will save these before my computer crashes. Again, make sure the alignment is off, base point, this corner, and select your swing. Same with this one. it looks like the alignment is on by default. There we go. So that one is already sorted as well. So if I now bring my cylinder back, so I'll draw my features first. So I'll draw my rectangle. So my diameter 4.5, I think it was, my radius. The diameter was 9.1. There we go. And then I'll press pull that. Okay. So I will now switch to conceptual. I'll use subtract. So that's the one that I did for my internal thread. So if I now move it, and now I'll use solid subtract again. So I've got my thread there. I can use another solid subtract for my bolt. So now what we'll do, I will use a section plane. that's it. Got my section plane now. This one. Just move it a little bit. So I've just moved it to show you that the tolerance is there. Obviously that looks a little bit strange because we're on conceptual, so the view is perspective rather than normal isometric. You can probably see it here, that there is a clearance between the internal and external thread. So yeah, that's it for now, guys. So any question, just drop me an email or drop a comment. Thank you very much for watching, and I'll see you in the next one.